Good evening, everyone. A warm welcome to Day 5, Session 9 of our AICT Training Academy sponsored faculty development program on quantum machine learning, bridging the gap between quantum computing and AI. We hope you have had an enriching journey with us so far and are excited as we are for this session. The topic for this session is large language models in machine learning. In this session, we explore the fascinating world of large language models and their transformating impact on machine learning and artificial intelligence, from their architecture to their applications. This session promises to give us insights into how LLMs are reshaping various industries. Our distinguished speaker for this session is Dr. Hari Mohan Pandey. He is a distinguished researcher in data science and artificial intelligence at the School of Technology, Bournemouth University, UK. He has been recognized among the top 2% of the scientists worldwide in the 2022 World Ranking list by Stanford University. Specializing in computer science and engineering, Dr. Pandey's expertise span artificial intelligence, soft computing techniques, natural language processing, machine learning, deep learning, and computer vision. His research interests are diverse, encompassing grammatical inference algorithms, formal language theory, software engineering, neurobiology, search and optimization algorithms, and AI-based web applications development. Dr. Pandey has authored over 120 scientific papers in reputed journals and conferences, including IEEE transactions, ACM transactions, Elsevier, and Springer journals. He has also written several books on computer science topics such as algorithms, programming, and evolutionary methods. His recent book is State of the Art on Grammatical Inference Using Evolutionary Method, was published by Elsevier. A dedicated academic, he actively serves on the editorial boards of the top tier journals, including Neural Networks, Applied Soft Computing, and IEEE Transactions on Evolutionary Computation, among others, where the contributes as an action editor, associate editor, and guest editor. As a postdoctoral research fellow for the S2020 Dream Forecast project, Dr. Pandey developed expertise in managing research projects independently and collaboratively. He now leverages this experience to supervise PhD and MR in students with high quality research articles and collaborate on funding proposals. His leadership in academia includes serving as guest editor for leading journals, delivering keynote addresses at international conferences, and chairing sessions and global events. Dr. Pandey is passionate about fostering collaborations across disciplines and geographies. He invites researchers worldwide to join him in exploring innovative solutions through multidisciplinary projects, joint funding applications, and impactful publications. His dedication to advancing the fields of artificial intelligence, machine learning, and related technologies underscore his influential role in the global research community. Dr. Pandey will guide us through the fundamentals and advancements of large language models, including their practical applications and future potential. This session is particularly relevant as LLMs continues to drive innovations in areas such as natural language processing, chatbots, and decision-making systems. Before we hand over to Dr. Pandey, we like to remind everyone to please keep your microphones muted to ensure a smooth session. If you have a question, feel free to drop them in the chat box, and we will address them during the question and answer segment at the end of the session. Now, without further ado, let's extend a warm welcome Dr. Hari Mohan Pandey as he takes us through this enlightening session. Over to you, Dr. Pandey.
Thank you very much. I think I'm audible to everyone. Am I audible?
Yes, sir. Yes.
Okay, great. So thank you very much for such a detailed introduction. Okay, so what I will do, I will share my screen and then I will start my presentation. Let me share my entire screen. I hope you can see my screen, right?
Yes, sir.
Can you see this coding window?
Yes, sir. Yes. It's visible.
Okay, brilliant. Okay, so I will start with a tester which I prepared this morning to start this session. So this tester session, the purpose of this tester session is to give a little bit description about one of the tool which is called as natural language toolkit. In short, we call it NLTK. And if you are interested in NLP research, where you are planning to apply some sort of machine learning algorithm and want to do something in natural language processing, including large language model, then this is one of the best tool you can start with. So the purpose of showing this tester code is because the reason is uh, my presentation will rely mostly on what I'm going to show in through this tester code. So initially, I have given some library in the beginning. I have just installed NLTK. So if you have worked in Python, I think you are already familiar with the pip command. So in these two lines, I'm just installing some library, and then I'm importing NLTK, the toolkit, to process one of the simple input sentence, which is this. So this is my input, and I would like to process this input. And what I want to do, I want to see how the system, how my, when I say system, it means that the computer or laptop or any handheld devices we use these days in our day-to-day life will process our input. So if this is the input we are processing, then how it will be processed? The system will first create tokens out of the input sentence. So you can see token. I'm simply using this function word tokenize, and the input is this sentence. This whole sentence is saved in this. So what will happen after running this function? The function will split this whole input sentence in the form of token. So you can see here, I am in my first faculty development workshop. So what will happen if you are applying some algorithm, some technique to process this language? I mean, I'm using English language. You can, these days we have many tools to process various languages. So if you are using any language, for example, currently I'm processing English. So if you want to process Hindi, then you can process in the same way Hindi can be processed, because each language follows some semantics, some grammar, and we can split the input sentence in the form of token, and then token will be processed sequentially or parallelly. This is the phenomena behind large language model or natural language processing. So this is the first step, and then we are tagging. We are verifying these tokens are worth. If you have studied English, the basic step of learning English or any language is what is the grammar behind the language. So in English, we in our schools we have been taught about noun, pronoun, verb, adverb, adjective, pronoun, article, so many things. So the system will apply a tagging process. So we will use the function pos underscore tag to apply tagging for the tokens. So you can see here the token for each tokens there is some tag associated with the tokens. After that we will apply chunking, and this is what, if you are from computer science background, then you might have studied a subject called as theory of automata or compiler construction. So you have seen this type of diagram, this type of picture in the book, and we call it context free diagram. There are many other diagram, but most of you might be familiar with context free diagram. So it is a tree like structure, and this structure system will use this structure to process the input information or input sentence. So my presentation will rely on this whole idea. So let me now begin with my slides. So machine learning, large language model, and its application. So I will be talking about these three areas. And considering the main theme of my presentation, I have given these 4 bullet points under the agenda. So in the beginning, I will talk about machine learning. So if you have previous background of machine learning, it's okay. If you have not studied, you have no idea about machine learning, what is machine learning about, you can get basic information about what is machine learning. Then what are the things you should know in order to construct your first machine learning model? If you are completely new, you have no idea, you have studied computer science, you have studied any other you are studying in any other specialization, or you are doing PhD, you are early career researchers, you are doing PhD, you are lecturer, you are senior lecturer, and you are intended to do something in machine learning, then you should know the building blocks of machine learning model, which will help you to follow certain steps in order to develop a good dedicated model for domain specific. And you can develop a domain specific model for solving the problem you have in hand. Then I will talk about large language model. So when I say talking about large language model, I will talk about basics of large language model and the steps one should follow in order to develop a large language model for a specific problem. And then I will demonstrate the application of large language model, transformer based large language model for healthcare sectors. So why I selected healthcare sector? Because these days I'm working on a project, and it is on healthcare, where I'm applying large language model to solve mental health issues. So that is the reason I thought, let me share what I have done. So introduction to machine learning. As far as machine learning is concerned, we would like to process the data automatically. So we machine learning in terms of definition, if someone is asking you what is machine learning, you can simply say that it is a branch of science where we develop some algorithm, we develop some model, and your model or algorithm will process the data to make certain decision. So you can see here some code snippet is given to decide the player category. So and it has why machine learning is very popular these days. If you will start reading the articles, if you are doing research, you will read some research articles, you will watch news related to machine learning, artificial intelligence in newspaper, in radio, or if you are watching videos in YouTube or in any other platform, then you will see some advertisement related to machine learning. Because it has a wide range of application in almost all the areas. So some of the area I have highlighted here, it's very common areas like sentiment analysis, fraud detection, object recognition, house price prediction. When I was doing my postdoctoral research, I was involved with one of the project under European Commission project called as Horizon 2020 scheme, and I developed autonomous driving system, which is and my algorithm has been used by Tesla for driverless car. So machine learning basically discriminate between two types of player. One is basketball player, another one is ballerina player, based on the information. So information is height and weight. So you can see here, height and weight are the data I'm providing to my algorithm, and my algorithm is capable to classify the player type. This is what I'm doing in this piece of code. So based on the data, it will classify. So but this type of simulation, if you are implementing just this type of algorithm, it is called as toy machine learning example, and it has no real world application. But if you want to become an expert, a good practitioner of machine learning or artificial intelligence model you want to use for your real world problem, you need to develop an algorithm which can process real world complex data set. But in order to do, I will just skip all these things, because all these things are given in my building block diagram. So let me just quickly brief you. So in order to process, in order to develop your model, we generally use the data. This is what I said. And we need to give training to our model, and then we will test the model. So whatever data set we have, we'll split the data set in two part. The first part of the data set called as training data, and second part of the data set called as test data. Now you should ask this question. If you are not asking this question, why you are splitting the data in two parts, training data and test data, then you are not paying attention to my presentation. So you should ask why training data set, why there is a need of test data set. The process is very simple. I generally use layman example to explain a complex topic. So it is as simple as we are studying in a semester, or in our school. Our teacher teaches us so many topics, and so when they are teaching us, they are basically giving training to us. And then when we are participating in the exam, they give some questions out of what they have been what we have studied in the semester or in the school, and that is for testing our knowledge. So the process is as simple as that. So during the training, we call it training phase. During the testing of the model, we call it testing phase. So this is during the training, and this is during testing. So we want our model should predict like a human. So prediction stage. So machine learning models are basically classified in various categories. So all in all, there are four. I have listed here three. The first one is supervised machine learning, unsupervised machine learning. There is one more called as reinforcement learning technique, which is used in large language model. So different types of data, like here you can see continuous data type, categorical data sets are there. You can use for model. Now this is very, very important. So building block of machine learning model, if you are interested to develop machine learning model, what are the steps you should follow in order to complete a dedicated machine learning model to solve a real world problem? So this is diagram. It has four phases. So initially you have to have a data set. So you need to analyze the data, and based on the data, you should select your model. You can choose pre-existing model or existing model, or you can come up with hybrid model, or you can develop your own model to process your data in order to predict the outcome. So initially, you have raw data. It may be labeled data or it may be unlabeled data. Like in the example which I showed in the previous slide, I used labeled data because I have already assigned the player type. So my data is labeled data. You may come across some data set where the data is not labeled. So you should apply unsupervised learning technique in order to deal with your data set. So you have a data set, and then you need to split the data set. As I said, the data set will be divided in two parts, training data set and test data set. And this whole process called as pre-processing of the data set. So this is the step number one. If you are intended to implement machine learning model for your problem, then the first step is pre-processing of the data set. And what pre-processing says: dividing the data set, analyzing the data set, splitting the data set in two parts, training data set and test data set. Some researchers or some practitioners, they divide the data set in three parts: training data set, test data set and validation data set. It is up to you. And then a learning algorithm. Now your model will come in picture, and this process called as learning phase or training the model. So what will happen? You will select your model. There are many machine learning model exist. Depending upon the data set you have, you can choose any, or you can use multiple learning models to you can use multiple learning models, and you can analyze which learning model is giving you the best result or superior result for the problem you have in hand. So what you will do, what you should do during the learning algorithm or learning phase, you should select the model. As I said, there are several models. You need to select the model, which model will perform the best for the data set you have. So if one model is giving you the best result, it doesn't mean that other models are not good. Maybe for your data set or the problem you are dealing with, and you have selected some model, that model is more suitable for your data set. maybe your model will give you the worst result for any other problem or the data set. So you need to select the model, and this process called as model selection, cross validation, performance metrics. You can choose several performance metrics like F score, F1 score, precision, recall. There are several quality metrics you should choose in order to analyze the quality of the learning or quality of the model you have selected. And hyperparameter optimization, this is very very important step in order to improve the quality of the model. And then you will get, once the learning process will be over, you will get your final model. This final model is based on the training data set you have used to train the model. Then, in order to check your model is capable to process unknown data means the data set you have created here, the test data. So you have not used this data set for your model. Now you will use this test data. So you can see you got the answer, that is label. Now you are using test data set, you are directly processing the test data set, sending this, using this test data set on this model. And your model is, if your model is capable to predict the correct outcome, it means that your model is capable to perform well. In order, so this process called as testing the model. In order to validate the model, now use any new data set which is not part of the data set. So this data you are using on this model, and if the model is capable to give you the correct result, it means that your model is predicting the correct outcome based on new data or any other data coming from real coming in a real time situation. So this is the overall process or steps you should follow if you are developing a machine learning model for your problem. Now I will begin with LLM. So what is LLM? It is a buzzword these days. Since last 2-3 years, LLM is very popular, and it has shown wide range of applications in almost all the field where there is natural language processing. So LLM, it is called as large because in order to train the model, we used large size of parameters, and it is advanced artificial intelligence technique. And why it is advanced? Because it predicts human like outcome. The model which you are developing here, it is still human involvement is required to analyze the model has predicted the correct outcome or not. But here most of the result will be far better than an ordinary person. But it doesn't mean that LLM is giving you the best result or it is giving you the correct result better than human. So that is the reason we call it advanced artificial intelligence system. It can predict or generate human like text. I hope you all have used chat GPT, something like this. So if you can ask any question, your model will give you the answer. So this chat GPT is a large language model based system. Here we use large parameters. So that is the reason we call it large. And large language model has capability, or it has ability to learn from the structure. When we say structure, it means that we are talking about the grammar, meaning of what you are asking, and model will process the input information. When I say input information, let me relate this with what I am saying. Suppose my question is, what is Apple? So this is my question. So this question, this is my input sentence. In order to process this input sentence, if you remember, I showed this type of this tester code right in the beginning. So it is exactly this. So in order to process this sentence means the sentence which I'm giving as an input to chat GPT. And large language model, that is this chat GPT, will process initially, it will convert this input sentence in the form of tokens, then part of a speech tagging, then creating that diagram in order to process the input sentence and provide you the information. This is the overall idea behind this chat GPT. So in order to give you accurate predicted outcome, it uses, as I said, it uses a large parameter. That is the reason we call it large language model. And it is not cost effective. Cost effective means if you are using free system, then you can simply work on, you can simply process some small data, or there is no guarantee that you will get accurate answer. But if you are solving a real world problem, you should process, your data set will be huge. And in order to process huge data set, you need high performance language model. So if you are trying to use high performance language model, you need to pay for word count. I mean the word. So you can see the price list. When I was submitting my proposal for the current project, I did all this calculation using this site. So you can see if you are using Chat GPT 4o, then you need to pay $2.50 for 1 million of input tokens. So you are processing your input sentence. My code is here. So for 1 million tokens, so how many tokens I have here? I have, for this input sentence, I have 1, 2, 3, 4, 5, 6, 7, and 8. And this has no relevance when you are implementing a large language model for real world application. You will get millions, trillions of input sentences, and your model should be capable to process such a rich, such a massive data set. So you should have the capability, your model should have the ability or capability to process such a huge data set. And in that case, you have to pay and you have to use. And uh, um, this amount you need to pay for processing 1 million of input token. If it is going beyond this 1 million input token, then you have to pay more and this price is for 1 hour. If you are using Chat GPT 4o just for 1 hour, this is the price you need to pay. You can see the price. All these prices are given here for different types of GPT. uh, so I have given the link here. And in order to give, when researcher developed the first large language model, what they did, they collected data set. And in order to collect huge training data set, they use books, they use website, and they use different types of data set in order to process their data. So this is just a basic introduction of large language model. I already showed you this Chat GPT for which we use in our day-to-day life these days to process or to know something. Now, the question here is, like I showed you, if you are developing a simple machine learning model, you should follow a basic building blocks for developing machine learning model. The same machine learning model will apply for any type of machine learning model you are intended to develop, including large language model or natural language processing, or for image processing, or for computer vision, or for weather forecasting, or in any other application. If you have decided that I should use machine learning model, you need to follow the steps which I showed you. Now, since the theme of this session is large language model, so I will focus only on large language model. If you are intended to use large language model for your application, then the basic step is we use a transformer architecture. Then we give training to LLM. Then we use prompting, and then response generation by LLM. So transformer architecture is very popular for large language model. Even OpenAI, Google, they use transformer architecture for developing their model. Then training, that is pre-processing, training, testing, validation, the same steps. Prompting is the input sentences which a user generally give as an input to the model, and then model process that input and generate the response. So prompting and response is, prompting means user's input, response means the output coming from the model. So transformer architecture, so it is most popular. There are, it doesn't mean that there are, it is just only one architecture. There are many other, but transformer architecture is very, very popular. It was introduced, I think, in 2026 or 2027, whereas deep learning model came into picture in 2006 and 7 by Hinton. So when you are using transformer architecture, basically your focus should be on these three. The last point is, the first 2 points are just to give an overview of what is transformer architecture, and it works on attention mechanism, the different types of attention mechanism you can use. One of the most popular is self attention mechanism. Then positional encoding. So what is the meaning of positional encoding? The meaning of positional encoding is, let me open this. So what is the position of the token in the sentence? So this is 0, 1, 2, 3, 4, 5, 6, 7. Simply the array based approach. I believe that if you have studied data structure, we use array based approach. So it is stored in an array like a structure, and then your model will start processing the data sequentially or parallelly. So what is self attention based mechanism? Focus on relevant part of input of a sequence or context while processing the input. Model computes how strongly it is related. For example, I have given one example. The girl found her book on the table. So here, girl and her, they are related. So this type of mechanism, the model applies to check the association within the sentence. So model calculates that her refers to girl as their relationship is stronger than her and book. So her is related to girl. Her is not related to book. Her is not related to found. Her is not related to table. This type of association, the model checks when we process any data through the model. Now, position encoding. What is the position of any particular token in the given sentence? So transformer process data in parallel, not sequential. So sequential means processing one by one. It is time consuming process. So in order to improve the performance of the model, sequential processing is not a feasible approach. So what researcher did, they rather than using sequential approach, they applied parallel approach. But if we are applying parallel approach, then it is hard to predict the correct token. So what approach they did, they applied, they have assigned a coding for each token, and this type of approach called as positional encoding. So what is the position of that token in the where you have saved your data? So 0, 1, 2, 3, 4, 5, 6. And if you have studied auto theory of automata in past, then you have studied Turing machine. So your reading right head is at position number 160, and the next token you want to predict is located at position, let's say 50. So your reading right head will move from 60th position directly to 50th position. So this type of mechanism is applied, and this mechanism is called as parallel or positional encoding and parallel processing of the input sentence. So here you can see the example. It says he read the book before going to bed. So he read the book before going to bed. This is the input sentence. Positional encoding. What is the meaning of this? It means that he, suppose if Hari is reading the book, so Hari will first read the book before going to the bed. So there is a sequence. Reading the book will come first, and then next step will be going to bed. So before, connect read and going to bed. So before is this token connects this read and going to bed. So this type of training, if you are giving to your model, then positional encoding helps a lot, and you can read and write, not write, you can just read based on the position of the token within the given sentence in an order. And then we use neural network, feed forward neural network. The most popular one is recurrent neural network. I have given so many slides. I will share the slides so that you can take a look. So feed forward network, just processing the data and giving training to the model in a flow. And here we will use transformer architecture to process the data in a parallel manner. And there are three types of approach the model will apply: one-to-one mapping, one-to-many mapping, many-to-many mapping for processing the input sentences. This is the overall approach transformer architecture applies. This is just a summary of what I showed you in last 3-4 slides. So input text, that is input sentences, breaking down into tokens, understanding the tokens with the help of positional encoding, then focus on important parts, that is attention. That is the reason it is called as attention mechanism, focusing only on those part which connects two or many sentences, or it has some association with someone enlist or presented in the sentence, input sentence. At attention, and then processing, that is feed forward and generating the output text. Now, so input and its pre-processing is done. Now, after pre-processing, training. So for training, training a large language model, we apply two stages: pre-training and tuning, as I showed you in basic building block of machine learning model. So it applies two steps or two stages. One is pre-training and then fine-tuning. Initially, our aim is just to verify our model is capable to process the data. We are not focused on model is giving the accurate answer, or what is the accuracy, percentage of accuracy of the model. We are not intended to achieve 99 or 100% or 98% accuracy. We are intended to verify that model is capable to process the data and give some result. So this process called as pre-training of the model. If the model is giving you some good or showing you some good behavior, then you can apply parameter tuning, and this process called as fine tuning of the parameter, in order to improve the performance or efficiency of the model. So this is the overall approach we apply for model tuning. So initially you have raw data, pre-training. So in the pre-training, as I said, some initial step will be performed, and then this is the overall fine tuning. So what will happen? Instruction tuning, reward modeling. Reward modeling, now reinforcement will come in picture. Your model will learn, check the outcome, it is meeting the outcome, or it is output is as per the expected outcome or not. If not, then reinforcement and learning by self. And then at the end, checking, that is prompting, user will give some input, and your model, this whole model will give you some output. I will explain all these things one by one. So what will happen in pre-training? Large text data set, pre-training phase. So what you are doing, you are completing some task, that is predicting next word, what will come in the next. Hari is going to read the book and then he will sleep. So Hari, what is the next word? Is or book or bed, what will come next? So this type of training you are giving, predicting the next word, what will come in the next, that is what is the next token. So this type of approach, or this type of mechanism your model will apply. So you need to give training to your model to achieve this. So what is the next word? Filling the missing word, if there is any word missing. If I'm using the chat GPT and I'm in the previous prompt, this is my prompt, I used what is apple, so it is grammatically correct. If I'm using apple is what, still model is capable to process this prompt or not and give me the correct answer or not. Yes. So it means that if there is anything missing in my prompt, model has the ability to understand what user is demanding for. So this type of approach you need to apply when you are giving to the training to your model. So filling the missing word. Or in another example, if I'm using GPT and I'm using what, apple, is missing. So model is able to process this or not? Yes, model is still able to process my prompt. So you need to give enough training to your model for missing word. Understand sentence structure. Yes, model should be able to understand a sentence structure. So these are the steps you need to follow in order to give pre-training to your large language model. And model learns patterns and language. Then you will analyze. Human involvement will come during the training process. You will analyze what you are expecting. Your model is giving the same or something similar or not. If yes, then your model is ready for fine tuning or a specific task, because large language model is very popular and it is gaining popularity day by day, because it is you can specifically design your large language model for domain specific. When I say domain specific, what does it mean? It means that you can develop your machine learning large language based machine learning model for domain specific application. For example, I am implementing large language model for mental health. I was attending one workshop 2 weeks ago, and one of the researcher from India, he is working on a project where he is trying to implement large language model for agriculture, because dialects in India, if you are talking to farmers in various parts of India, like if you are talking a farmer in Maharashtra, his language he is using Marathi. Whereas if you are talking to a farmer in Haryana, he is using a different language. So is there any common platform which can be developed and shared with farmers, and farmers can use that system to get some awareness, gain some information about what a farmer in Maharashtra, what he is doing, and what a farmer in Haryana or Punjab or Uttar Pradesh, what they are doing for the same crop. So this type of information can be this type of platform can be developed using large language model. So if you are developing such type of platform using large language model, what you are doing, you are basically utilizing artificial intelligence machine learning model, large language model for domain specific. And here the domain is agriculture, clinical practice, healthcare, some sort of security, computer vision. So if you are developing your model, if your model is dedicated for a specific domain, then you can use large language model if you believe that information can be processed in the form of text. Now, fine tuning, what will happen in fine tuning? Large data from the internet, or if you have data stored, you have the storage capacity, good infrastructure, you can keep the data set in your own environment. And then unsupervised pre-training. Now, here supervision is not required. Now we want to analyze model is able to perform the task on its own or not. And then large language model will perform the task. It means that your model is capable to predict the outcome without human involvement, and you can develop it for a specific task if you are giving labeled data and for a specific task for fine tuning. Reinforcements play a very important role, significant role in large language model, because model learn from itself. For example, one day I was checking LLM is capable to tell me who is Hari Mohan Pandey. So I just use who is Hari Mohan Pandey. And model was not capable to process this information at that time. Now I provided some information about myself, and now model is capable to process who is Hariman Pandey. So it means that it is not just processing the data which is ready with GPT. Model is keeping the information, whatever we are processing, model is creating, model is increasing its knowledge base and to process any future prompt. So this is reinforcement, learning from itself, and based on reward and reinforcement learning process. Prompting, I already explained what is prompting. Prompting means the input sentence. In a simple way, if you want to understand what is prompting, this is the query which I have given. This is prompt in LLM. This is prompt. So there are different types of prompt. Uh, you can see here zero shot prompting. What is zero shot prompting? The model is asked to perform a task without any prior example. If you are processing something and model has no information in past model has not received any such kind of queries in past, it is called a zero shot prompting, where model has no information and model want to understand the prompt or the query and want to predict something and generate some text for user's query. Second one is few shot prompt. This model is given uh, this model is given a few example to help in it understand the task. You are processing something, you are providing some information so that the model has created some knowledge base for of related information in order to process, and then when you are asking a query, your model will collect the information from the knowledge base and provide the response. Now, instruction prompting, here you are giving a specific query following a good structure of the code. The prompt. For example, instruction prompt is like this is instruction prompt. Here I'm using this who, then this question mark. So this is instruction. Whereas if I'm asking Hari, this is few shot. So here the answer will be different. You will get little information if the information is stored in the knowledge base. Whereas if you are using instruction based, you are applying proper instruction, you are writing your prompt in a correct way, then you might get good response. So the way a prompt is constructed can greatly impact the quality of relevance of the model's response. So model response will vary according to the prompt you are giving to the model. According to the query you are asking, model will change its response. And if you want to get a good response, you should ask question or prompt accordingly. For example, let me change something to explain what is the meaning of prompt. Suppose this is the paragraph, the text I am taking from here, and I'm writing here rephrase, then I'm using this text and in uh, 200 words and then question mark. See what will happen. Model will collect the information from the prompt and process the information accordingly. So you can see I have not given any information related like gate exam or technical job interviews, but based on the knowledge base, this GPT language model believes that if this gentleman is doing something in academic, he might have done this gate exam or interview preparation or job related things in past. So he has collected the keywords, that is the tokens, using positional encoding and related with what prompt I'm asking and providing me the final response, that is generating the response accordingly. So this is instruction prompting. Now, application in mental health. I will now briefly talk about mental health application of large language model in mental health. So, mental health is a key challenge worldwide these days, and nobody want to accept that you are mentally disturbed. I'm disturbed, I will be able to finish my project within the given time in 10 months or not. Someone, you are disturbed, you will get promoted in your job or not. PhD scholar is disturbed, mentally disturbed, my paper will get accepted or it will be rejected by the journal or not. Should I meet my supervisor will scold me because I have not done good progress. So everyone is mentally disturbed, they are struggling. And like you are sometimes I feel disturbed after seeing my friends are putting post on Facebook or Instagram, and I feel like the whole world is enjoying except me. I'm busy in my work, I'm not getting time for making fun or enjoyment. So we are mentally disturbed, and considering this, I prepared a proposal and I submitted it for granting, for getting the fund. And where my aim is to apply large language model to process the type of depression or type of mental health a person individual person is suffering with. So here I have given some information related to mental health. So mental health is a critical problem worldwide. In 2009 report, 970 million individuals, they accepted that they are suffering with mental health, and it affects 12.5% global population. So the main issue is anxiety and depression, and you can see it affects 301 millions and 280 millions individual respectively. And it is not just the individual health. If you are not mentally fit, you are not fit, you will not be able to focus on your work, and it will affect not only your self or your family, it will affect overall economy. So you can see here the estimated number is US dollar 5 trillion economy, global economy got affected due to mental health, and it needs a serious attention in order to address this problem. So here I have given some facts related to which came in 2024 in September by WHO. And here you can see this second point: 70,000 suicides every year worldwide, and it is a serious concern. And one need to pay attention in order to address this problem. So I have given some mental health information. So there are some research on mental health where, I mean, where it is not some research on mental health. There are large number of research on mental health and particularly on depression. But researcher have started utilizing large language model to check its ability to process mental health data for analyzing the person is suffering with mental health or not. So in 2020 21, few researchers, they attempted to apply large language model to analyze depression from social media footprint. Like if I'm in depression, uh, I will delete my photograph status from WhatsApp. If I'm depressed, I will block my Facebook account or Instagram account. If I'm particularly disturbed by someone, I will block the persons. If I'm disturbed due to weather or due to any other reason, I will my post, the text I will post on my social media will change according to my mental health condition. So based on social media footprint, what type of information I'm posting on social media, they try to figure out the person is in mental stress or mentally disturbed based on the type of post they are posting on various type of social media. So they targeted Twitter to collect the information, and they used Twitter data and they as an input for giving training to their large language model, and they predicted that who is suffering with mental health condition or depression and who is not suffering with mental health condition. So this type of approach they applied. So here I have given how they detected. So some research work you can see, this is a very important research area in worldwide. And if anybody is interested to work in this field, then you can work. This is one of the most popular area, is particularly in UK, Europe, and US. A large number of research groups are working on in this area. And if you have completed your PhD and you are looking for postdoc position or research fellow position, then you can propose some your idea to some professor, and if they will like your idea, they might invite you, or they will collaborate with you. So finding from literature. So what research literature says, what they did in order to predict mental health condition, they applied artificial intelligence. Some researchers, they applied machine learning. Some researchers, they applied deep learning. As I said, since last 2-3 years, few research groups, they attempted large language model for mental health condition. That is the reason the text is given in red text. This is just a quick summary of existing literature, what the researcher did in past when they applied AI, machine learning, or deep learning. Nobody has used large language model. So two common approaches they have used in based on this literature summary. So two common approaches. The first one is lexicon-based natural language processing, and the few researchers they use transformer-based language model. So only few researchers have used a transformer-based language model, and the outcome reveals that transformer based language model, that is large language based model, showed high performance in order to predict the mental health condition of individual person. So that is the reason it is gaining popularity in healthcare sector. Some more research articles are highlighted here where researchers have used transformer based large language model for mental health. So these are um, pre-existing, I mean existing pre-trained large language model which you can use for your problem. If you want to use, you have not to worry about developing your own model. If you are thinking like if I will start, if I'm intended to use large language model and I have to first develop large language model, then I will try to use validate that model for my problem. Then this is not the case. What you can do, there are many companies, they have their own, I mean they provide um, large language model. So what you can do, pre-trained, it is called as pre-trained large language model. So you can just call or you can just integrate pre-trained large language model in your code, and you can come up with your own result for any specific domain or any specific application. So these are popular pre-trained transformer based large language model, and their comparison is given here. The parameter they can process, if you remember I showed this word, millions of word token here. So their capability, and they are free. It is not like you have to pay all the time. So if you want to just verify, you do not want to pay, you can use, and they have the ability to process such a huge parameter. So you can see if you are using distill bird, then it can process 66 million of parameters free of cost. If you are using bfsc pre-trained model, it can process equivalent to 110 millions of parameters. So you can see, and uh, some other parameters are given in first few columns. So common data set they used, they collected data set, most of them they collected data set from Twitter, Facebook, Instagram, in order to analyze a person is suffering with depression or mental health condition or not. So these are the common data sets. If you want to try, you can try. So what I did, I selected this data set, TTDD data set, because it consists of both positive as well as negative. So positive means the person is suffering with mental health condition, whereas negative, it represents that the person is not suffering with mental health condition. For my own experiment, in order to verify LLM is capable to process the data or not. So the challenges I here extracted feature, location of the post, relative and depression onset, number of posts, and duration of timeline. These challenges, what is the meaning of these challenges? The challenges, these challenges highlights that uh, today I am in mental health, I'm depressed, so my post is different, whereas in the evening at 9 o'clock I'm happy, so my post will change. So I'm mentally disturbed, or my mind mood is fluctuating. Tomorrow I'm happy, day after tomorrow I'm happy, on 15th of January I'm happy, 16th 15th afternoon I'm happy, 15th evening I'm unhappy, 16th I'm unhappy, 17th I'm unhappy. So if we are processing data for one day or for a specific time, then it is hard to say the person is really having mental health condition. So these are the challenges which we have, in the project we have noticed. So that is the reason you can see number of posts and duration and timeline. I'm more energetic in the morning, or I'm more energetic happy in the afternoon, or I'm more happy in the evening. I'm happy on Sunday or I'm happy on Monday. Oh, I have to go to office. So duration and timeline. So in order to analyze the exact mental health condition of the person, whatever research work done in past was not accurately finding the mental health condition of a person. So in order to address these challenges, so some methodology, so again the same models are explained, I already explained. So for the computer simulation, what we did, we collected data set. I already said TTD data set was selected. The reason is it consists of both positive and negative data set. I already briefed you what is the meaning of positive and negative. Then preparation of the data set, basic building block, which I explained right in the beginning of the presentation. We need to rely on what is basic building block: pre-processing of the data, learning, final model, validation. So preparing the data set, that is the pre-processing, training and testing of the model, learning, and then finally validation of the model. That is point number C. The system architecture where we implemented the program, we used Google Colab, NVIDIA T4 GPU, 15 GM, and GPU RAM. It's all freely available. If you are interested to implement, you can implement. Some more information about data pre-processing. You can see dataset, TTD dataset, and this is another dataset. And rather than just relying on one day post or in a specific timeline post, we used timeline of post. So 2500 Twitter post timeline. So for one user, 2500 posts by one user. Suppose I am the user and my model, I am using a model to analyze my mental health condition. My model will not just process one post, it will process 2500 posts, and then it will predict my mental health condition. I am suffering with mental health depression, or I am not suffering with mental health condition. So this is the idea. And in one go, 10 posts in a timeline. So you can see this is pre-processing. This is how the posts have been created. Set 1 to 10, then another set 1 to 30, another set 1 to 40, another set 11 to 30, another set 12, 21 to 40, because we want to shuffle the data set to resort to avoid any biasness present in the post. And then preparing the data set, creating empty list. Then some steps have been applied. 10 posts, this is what I already showed here. 10 posts at a time, 1 to 10, 1 to 20, sorry, here 10 posts, 10 post timeline at a time. And then after this step, obtaining a clean data, because if someone posts any information, it consists of some personal information, and in order to process, in order to develop a generic model, you need to remove personal information from the post. So this is cleaning the data set. And basic model architecture, downloading the data set, post extraction, cleaning the data, the same I already explained. Splitting the data set in training data and test data. Tokenizing, I explained what is the meaning of tokenizing, what is the meaning of position encoding. Then pre-training of the model and fine tuning of the model, and then my final model is ready to process. Then for tuning, the fine tuning of the model, these are the steps which I applied. I created a data set in text file. To visualize the data, word cloud, I showed you the word cloud. This is a word cloud. Created the word cloud and preparing appropriate training sets, then creating a training set, then splitting the data, training and validation, because for training, testing and validation, and then fine tuning the model. So the same steps are presented here in the form of block diagram. This is for model training and validation. I will demonstrate with the help of some results are presented here. And then this is concluding remark. What I'm going to show here is, so this is the model training. This is model development, model training and testing. So depression detection from social media. So my data set is stored here, timeline post. And this is what I showed you. Per file, I want to store 1,000 record. negative record is 3800 negative record, negative positive to files, CSV files I am creating. The data set is stored in my drive, and I have mounted the drive. So this whole code is model training using transformer based large language model. Here you can see I used NLTK, which I demonstrated right in the beginning. This is the code where I used NLTK. This small code I created just to demonstrate how NLTK works. And this code is where I used NLTK to process a real world problem. And then I'm analyzing lowercase, multiple character, removing other language. Like sometimes we use like good night. So for night we use N8, or some by, it is not a BYE. Some people write BY or just B. Happy birthday, HBD. So your model should be able to understand HBD means the user want to say happy birthday. So this type of approach I applied to analyze the input information. So this whole code is for model training and model testing. And then, and here you can see some people, they post emoji, happy emoji, crying, they show that they are crying, they are laughing, laughing emoji. So if there is emoji, then your model should be able to understand the meaning of what user want to user want to say with the help of emoji. So meaning of emoji, all these things. So then training the model, reading the file. This is the text file. If you see, I showed you here how I'm processing the data. uh, Here I'm using, where, see here, yeah, here I'm processing the text data .txt data. So the text data, clean text data. And so the same code is presented here. And so this is for the training the model, for the training of the model. So these are different model, pre-trained model I used, and I incorporated all these models from Hugging Face. Hugging Face is a platform which you can use. Let me show it to you. Hugging Face. So if you are using Hugging Face, you can directly import the model from here. You can import model from here. If you are using you are interested to use BERT for a BERT model. So just use the model, and then you will get all the information related to model. Even the code, you can directly use this code, and you can train the model for the problem you have in your hand. So this is a generic structure of the model, and once your model is ready, you can deploy your model on Hugging Face, so that the researchers worldwide, they can use your model for their application. This is the beauty of this Hugging Face model. uh, so I was here, so I used all these pre-trained model from Hugging Face, so no need to worry about the development of the model from the scratch. And then, in order to validate my model is working fine or not, I created testing the model code. So here, if you will see, yeah, so here I want to check positive and negative. So negative post, how many posts I want to see first, let's say 25 posts. And then if I will submit here, my model will process the data. So my data is stored in this location. The file, the txt file is stored in that location where the text posted by or the prompt posted by the user is stored. So my model is collecting the information from that post and then processing it. So you can see Twitter 1, Twitter 2, Twitter 3, Twitter 4, and based on that, this model will tell me the person is happy or sad or something. This is the idea. So you can see the person is happy. I mean, person is not mentally disturbed. So positive. If I'm using any other, I need to run it again. Let's say negative post. I'm using negative post. How many negative posts? I'm using negative post, but it doesn't mean that person is mentally disturbed. Processing the data from the whole data set, and based on the different person negative. So this is the overall idea of what I did here based on the data set which I collected from the Twitter. And as far as the conclusion, so some comparison is shown here for different pre-trained large language model. I'm not going in detail of all these things because it can vary according to your problem you have in hand. So this is just a comparison of different model. So it doesn't mean that if one model is showing better result as compared to other, it doesn't mean that the model is not good, or it is you should not use. Maybe for your problem, it may give you a good result as compared to any other model. So my approach showed 87, I mean my model showed 87.8% accuracy when I compared with benchmark, which is 89, and this is early, based on the early finding. And the infrastructure which I used was also very low as compared to what was shown in this research. So conclusion is presented here. So based on as far as the conclusion is concerned, I will simply say, I hope this presentation will help you to understand the steps you should follow for developing a machine learning model if you are at early stage of your career. If you are intended to apply large language model for your problem, then I have presented uh, basic information about large language model and the steps you should follow in order to develop large language model and the application area. So if you are interested to work in healthcare sector or agriculture sector or any other sector where you are intended to apply large language model for solving the problem, you can just think about how you can fit a large language model for your problem. The challenge is getting or implementing such a huge model, I mean model using huge data set. So no need to worry about that. You can use Google Colab, you can use this notebook, Jupyter notebook, and you can use cloud sources to process the data and to check your idea, your algorithm is working for the data set, you are able to implement the model for your problem or not. So you can check all these things at the early stage, and then later on you can pay a small amount to solve the problem, and you can even sell, you can deploy it on Hugging Face, you can sell and you can earn money out of this. So that's all from my side. If you want to go, if you want to get more information, technical details, I have added few more slides here, the input sequencing, how it will be processed in terms of technical, more technical, because my assumption when I prepared the slide, my assumption was the session will be focused on computing only. Then I thought that maybe if other staff who has no previous background of computing, if they are attending, then how they will be able to understand all these things. So I will share all these things with you guys, so that you can take a look. So this is how the data will be stored and how the activation function will process and evaluate the performance of the model at the hidden layer, and then you will get all these things, I mean the final result. So I will share all. So that's all from my side. If you have any question, I will be happy to answer your questions.
Participants, if you have any question, ask them. No questions, sir. Thank you so much.
Okay.
Thank you so much, Dr. Harimohan Pandey, sir, for this highly insightful session on large language models in machine learning. Your explanations and real world examples have given us deeper understanding of this transformative technology. Your expertise and the clarity with which you presented complex concepts have left us all inspired and better informed about the capabilities and applications of LLMs. We are confident these learnings will significantly impact our teaching, research, and professional practices. To our participants, thank you for your active engagement. Please take a moment to fill out the feedback form for this session available in the chat box. Your input is invaluable to us. That concludes session 9. Thank you once again, Dr. Pandey. and to all the participants for making this session a success. We look forward to seeing you in the next session. Have a great evening. Thank you, sir.
Okay. I can leave now, right?
Yes, sir.
Okay. Thanks a lot. Okay. See you. Bye bye.
Bye, sir. Participants, there will be one important announcement. We would like to inform you a change in the speaker lineup for session 10, originally scheduled to be led by Dr. Kusum Yadav. Unfortunately, due to a flight delay, Dr. Yadav could not join us for today's session. However, we delightedly announce that our new resource person for this session is highly accomplished, Dr. Ashok Z. Matani. Dr. Matani brings him a wealth of knowledge and expertise in quantum computing in semiconductor industries. So please wait for 5 minutes. So without further ado, let us welcome Mr. Ashok Ji Matani with a big round of applause as he shares his expertise on quantum computing in semiconductor industry.
Good evening, friends. Our topic for discussion is quantum computing in semiconductor industries. Now, we go one by one. What is quantum computing? Of course, your training is totally on quantum computing. I will not go much deeper in that, but just how it is related in semiconductor industries. This quantum computing is multidisciplinary field comprising aspects of computer science, physics, maths that utilize quantum mechanics to solve the complex problems faster than the classical computers. This field of quantum computing includes hardware research and application development. Now, how it is used in semiconductors? Now, this quantum computing, it utilizes quantum mechanics to solve the complex problems faster than classical computer. It has emerged as the transformative technology, and combined with semiconductors capabilities, it opens new processing and information technology frontiers. Here we are finding one screen or a picture of that in which how this is used. This dream of ultra fast and efficient quantum computers has been for decades. We have seen that when the computers were introduced in India 35 years back, the speed and size of the computer was just like a TV screen, and the speed was very, very meager. Considering today's speed of the supercomputers, even nanotechnology is now entering, and fast developments in semiconductor industry also. Then why quantum computing is important? This computing has the potential to solve the problems that are beyond the capabilities of classical computers. It provides exponential speed up in tasks such as simulating complex molecular structures, optimizing intricate systems, and strengthening the cryptography. This quantum computing can revolutionize the design process and drive innovation by producing faster and more efficient chips in the semiconductor industry. Even cloud services have made these quantum machines more accessible. Now, these quantum simulators are also making significant progress in various fields, including molecular energetics and many body physics. Even some companies like IBM, Google, D-Wave, Microsoft, and others are using this quantum computing, and these are the means leader in the markets. Now, this quantum computing is seen as the next logical step in production of faster and more efficient computers, and advancements in nanotechnology and semiconductors have helped to bring quantum computing closer to mainstream in the recent years. This relies on certain physical characteristics, physical orientation for desired computing power. It is not the software, it is hardware technology. Hence, the types of material used to construct are more important. Here we are finding there is slight difference or a comparison between this quantum computing and classical or the conventional computing. Here in quantum computing, this calculates with qubits. Here what we call that qubits, which can represent 0 and 1 at the same time. Here classical, it is calculates with transistors which can represent 0 and 1. This here power increases exponentially in proportion to the number of qubits, whereas in conventional it is 1-to-1 relationship. Then quantum computing have high error rates and needs to be kept ultra cold. Means we require comfort and more sophisticated conditioning, handling, processing, or handling of that are packaging aspects. Whereas it is classical computers have low error rates. This is well suited for tasks like optimization problem, data analysis, and simulation, whereas conventionally is used everyday processing in different classical computers. Now, how semiconductors role in advancing computer computing there? This quantum computing heavily relies on selective approach to physical materials, and this semiconductor materials exhibit numerous quantum degrees of freedom, leading to rapid interaction and coherence of qubits. These advancements in atomic engineering and sophisticated semiconductor fabrication technologies have mitigated these challenges in paving for further progress in quantum computing. This understanding the fusion of quantum computing and semiconductors. This quantum domain of semiconductors unveils the domain of complexity and fascination, with comprehensive serving as a gateway for harnessing the potential of quantum mechanics. This role of semiconductors here. These are the foundation of modern electronics, powering devices from smartphone to supercomputers are, because we are now finding new 5G mobiles are latest 5G mobiles which are introduced 3 months back, and still these are yet to reach the remote place of the for mobile phone users. And the new developments which I have read on news report in TV channels that India, our scientists, our engineers are working on 6G technology, and this will be 1,000 times faster than this 5G. And imagine how much these innovations and the speed of the progress in technology is there. Still, we are yet to reach the every corner of India, remote places of 5G, and new technology 6G is on the doorstep, and this will be 1,000 times more speedier. Imagine what can be the situation of, I mean, so mobile data and other transmission technologies. This is Force Fusion Juries, that is RWTH Aachen University and Leibniz Institute of High Performance Microelectronics are pooling their complementary expertise in field of semiconductors and quantum technologies. They are leading, they are working on this, research work is going on this. Collaboration on the development of scalable semiconductor supercomputer quantum bits, that is qubits, that will make it possible to achieve quantum computers with millions of qubits. Here we are finding how these tiny particles are there, tiny materials are there. These quantum bits in semiconductors, these quantum bits are qubits, are realized using properties of semiconductors such as electronic spin, which can serve as the basis for qubit operations. Then quantum dot technology. These are nanoscale semiconductor particles that exhibit quantum mechanical properties. These are used to configure single electronics, offering promising platform for cubic implementation. Then future of quantum computing in semiconductors. These quantum dots represent groundbreaking advancements in semiconductor technology, poised to redefine our understanding of electronics. These minuscule particles means nano, just like nanomaterials. These measuring only a few nanometers post distinct optical and electronic attributes. And now from cells to lasers to quantum computers, down quantum dots are now making their presence in cutting edge technologies. Slight challenges and opportunities are there. Challenges are there because when technology is coming, when it is new, slight limitations are, slight challenges are there, but these can be overcome as and when technology progresses. This is overcoming this quantum decoherence, means semiconductors face the challenge of maintaining quantum coherence for qubits, necessitating error correction and qubit stability breakthroughs and collaborative research efforts, because now more collaborative research efforts will be required. Only very meager or negligible amount of these researchers or these advancements are happening at the world level. For reaching this to the maximum population, we require this collaboration, MOUs with market leaders, MOU with advanced research universities and other companies which are working on this specific to this high new emerging area, and we to make this collaboration between the semiconductor manufacturers, quantum hardware developers, and research institute to address the technical challenge and accelerate the realization of practical computing in semiconductors. This convergence of quantum computing semiconductor promises to unlock unprecedented computational capabilities and drive innovation across various industries. As research and development efforts continue to advance, integrating quantum computing with semiconductor is promising a new era of technical prowess with potential to revolutionize computing, communication, and beyond quantum computing semiconductor, a frontier of exploration presenting immense opportunities for progress and discovery in science and engineering. These advancements within the semiconductor sector have been instrumental in propelling this quantum computing. This semiconductor industry is spreading these endeavors from pioneering new materials and fabrication to leveraging AI, artificial intelligence, to optimize design and production workflows. Even slight hurdles in quantum computing development are there. Technology holds immense promise and potential in transforming data processing and analysis methodologies. There are different quantum computing applications and examples. So these are the various areas where we are using these artificial intelligence, better batteries. These batteries are for electrical vehicles, then cleaner fertilization, cyber security. This is one of the most promising and emerging area in which now cyber criminals and cyber threats are increasing as the technology is increasing. This is the other area where we have to take special prevention and protection from our side also. Then drug development, electronic materials discovery, financial modeling, solar capture, traffic optimization, and weather forecasting and climate change. Even this discovery by Microsoft and Quantinuum addresses this problem and reignites the heated race between top tech companies like Google, Microsoft, IBM to conquer this quantum computing. These are different companies using quantum computing. That is IBM in New York, Carmack in New York. This quantum computing and AI, they prove to be mutual backstretchers. The advances in deep learning, this is the branch of AI, machine learning, deep learning, big data analytics, all these are coming under AI. This will likely increase our understanding of quantum mechanics. IBM's quantum research team has found that entangling qubits on the quantum computer run on data classification equipment cut the error rate in half compared to unentangled qubits. Means they have reduced this error 50%. This IBM's research came in wake of another promising machine learning classification algorithm in which this quantum classical hybrid run on 19 qubit machine built by Rigetti Computing. This harnessing this quantum computing static distribution has the potential to accelerate and improve machine learning related to pure classical performance. Then another company, that is JP Morgan Chase, it is also in New York. Majority of the companies we are finding these are in US. With this at IBM's Q network, this JP Morgan Chase stands at sea of techno focus members, and the hugely profitable financial services companies would want to leverage paradigm shifting technology. This entire financial market can be modeled as quantum process where quantities are important to finance such as covariance metrics emerge naturally. Lot of research is focusing especially on quantum's potential to dramatically speed up the Monte Carlo model, which essentially gauges the probability of various outcomes and their risk. This Microsoft location, that is in Redmond, Washington, US. This much of the planet's fertilizer is made by heating and pressurizing atmosphere nitrogen into ammonia, and it is in since 1900, means nearly 125 years since back this fertilizers are made. But now this, with the help of this Haber process through reversionary, proved quite energy consuming, and this Haber, which accounts for more than 1% of greenhouse emissions, then they have now making developments in this using quantum computing. And now researchers from Microsoft isolated the scope factor molecular that is necessary to simulate. Then Rigetti Computing, that is in also California, US. This recent research into weather computing, quantum computing, is improving weather prediction. Because even we have seen that in July in India, this Biparjoy cyclone, its impact was very, very negligible because of this capability of our super, means our ISRO team and other satellites utilization in this, and only one person lost his life because of this Biparjoy cyclone. This is the very negligible, means negative or destruction side of this any cyclone in India up till now. Because its total progress, its path was totally monitored and governed with the help of satellites by ISRO scientists. And hence, whenever it was progressing, its path was monitored, and accordingly, remedial measures were undertaken by local authority, police, and municipal corporations, and hence preventive measures were undertaken by municipal corporation authorities, and hence only one person lost and very negligible infrastructure loss was there because of the cyclone. Because up now we have seen these cyclones are causing heavy casualty and heavy destruction, but before the cyclone we have monitored this progress because of the supercomputers and quantum computing. Even this post quantum, that is in London, the company. Even this National Institute of Standards and Technology (NIST) announced for 4 cryptographic models in last 3 years, and it is in process of standardizing the algorithms. And these experts are working to precisely what computer focused security needs. Then this protein cure is in Ontario, Toronto. This company focuses computational heft on molecular simulation. Specifically, protein behavior is Toronto-based biotech startup Protein. It partners with quantum computing leaders IBM, Microsoft, and Rigetti, and pharma research outfits SRI International, AstraZeneca, to explore quantum computing's potential in modeling the protein. These now proteins are engineered for targeting medical purposes because now new developments are going in a health sector, healthcare, and medicine, pharmaceutical industry. This, as Boston Consulting Group noted, merely modeling a penicillin molecular would require impossibly large classical computer with 10 to 86 power bits. For these advanced computing computers, quantum computers, this same process could be a snap, just like it is. Means this will be very easily handled. And discovery of new drugs for serious maladies, just like cancer, Alzheimer's, and heart disease, because we are finding this cancer, which is identified in majority of the cases when it is progress and it is almost at the final stage, majority of the cases. And even our medicines and these doctors and these medical professionals, they are unable to save the life of a cancer patient. But with the help of this quantum computing, we now this the detection of cancer is easily diagnosed, and now the life of these patients is saved. Another Alzheimer's, it is related with brain. Means people are forgetting these things, and heartbeat or heart disease. This is one of the main reason of death throughout world. Even the cardiologists, which those who are masters and surgeons, they are also dying because of this massive heart attack. But with the help of this now, so this quantum computing, these three diseases are three abnormalities are now diagnosed, and now preventive actions, and we are saving the life of these patients. Then this is this Daimler truck, means it is in vehicle company, automobile company, that is in Germany. This quantum computing's potential to simulate quantum mechanics could be equally transformative in chemistry related realms beyond drug development. Here, this car batteries, this company is working on car these batteries. This car, German car manufacturer, of course, this was the Mercedes-Benz previously. They announced 2 distinct partnerships with quantum computing powerhouses, Google and IBM. These electrical vehicles are now using mainly based on well-functioning cell chemistry of the battery, because new developments are going in batteries. Because the electrical vehicles now we are having, even Government of India have made one circular, Ministry of Road Transport and Ministry of Industries have made this circular, keep from 1st April 2025 onwards, automobile manufacturers, they have to manufacture the vehicles, those who are working on green fuels and electric vehicles, means they will be stopping their production of these two-wheeler and four-wheelers, those which are presently running on gasoline, means petrol and diesel. These will be now stopped, manufacturing will be stopped, and only green of these vehicles which are running on green fuel, they will be made, manufacturing will be done. And this electric battery, it is costing more than 70% of the weight of the electrical vehicle, as well as 70% cost of the vehicle is on batteries, electrical vehicles. Hence, this quantum computing is providing this promising results in this. This, with the help of this quantum computing, these more sustainable batteries plus autonomous vehicle choked traffic future and accelerate its logistics also. Even this Volkswagen, it is also automobile company, it is of Germany. This company exploration of optimization brings point worth emphasizing. This traveling salesman problem is used in computation. It aims to determine the shortest possible route between multiple cities, hitting each city once and returning to the starting point. Known as this optimization problem, which we have learned, and we are teaching this in operations research subject or supply chain management subject. With the help of this quantum computing, now it is easy to operate and more efficiently we can have. Even this D-Wave and Volkswagen have already run pilot programs on number of traffic and travel related optimization challenges, including streamline traffic flow in Beijing, Barcelona and Lisbon. Imagine the situation in Beijing, in Tokyo, in Delhi, in Bangalore. Of course, so majority of our participants are those who are here in this meeting are Delhi. They are knowing the traffic congestion problems. And even from Bangalore city to Bangalore airport, it is nearly 50-kilometer distance, and it is taking 2 hours in traffic jam. Means imagine what is the traffic condition in India or in Bangalore. In Delhi also we are having traffic problems, and because of this traffic problem, so this during COVID time, early 2020, the majority of these victims were metro cities, means Delhi and Mumbai people, citizens. Because of this, one was of this air pollution was because of this traffic jam and air pollution, and this air pollution affected the lungs, and this COVID was related with lungs infection. Hence, majority of this means Delhi and Mumbai people, they were affected because of this COVID. Now, with the help of this quantum computing, this fleet of buses traveled along district routes are now tailored in real traffic conditions with quantum algorithms. Then INQ location, that is College Park, Maryland. This is used in hydrogen fuel, sustainable energy alternatives, where without the use of this, we are using this greenhouse, means minimizing these harmful effects of greenhouse gas emissions. Even most hydrogen fuel production is currently rooted in fossil fuel. Now, we are having these hydrogen vehicles in Delhi also. Hydrogen buses are running. Even new hydrogen train is means scheduled. Probably it will be running within this week or next week between Jind and Haryana. Sonipat and Jind in Haryana, and its cost is 80 crore rupees. Indian Railways, they have made this hydrogen hydrogen train, and this will be running on this, means trials will be running on this 80 crores budget or 80 crore cost is of that train. Now means Government of India is working on this. Even hydrogen fuels are now working. Even yesterday, Honorable Prime Minister Shri Narendra Bhai Modi has also commissioned and launched new one green hub or hydrogen uh, uh, gas hub in Bhubaneswar in Odisha yesterday. Here, this electrolysis, the process of deconstructing water into basal hydrogen. This is the our hydrogen vehicles. This in 2019, IonQ, this performed the first simulation of water molecule on quantum device. Even in 2022, I can release this fourth, that is new generation of quantum systems, allowing software configurability and greater flexibility for researchers. This company IonQ have released two new quantum computing systems and found way to communicate or means communication between quantum systems. Even new developments are going on, in which I have read in newspapers and on the news channels that water will be used as the fuel in the research is going on in American universities. Even ammonia is another green fuel where research is going on, in which the new fuel, emerging fuel will be ammonia. And after that, water, if water is used as a fuel, no problem, and no problem of any environmental degradation, no problem of pollution, and no problem of petrol and diesel costs. This developments is going on at world level. Then in Plequeton, that is in Colorado, this previously known as cold quanta. It is known for its use in cold atom quantum computing, in which laser cooled atoms can act at the role of qubits. With this method, fragile atoms can be kept cold while operating system remains at room temperature, allowing quantum devices to be used in various environments. This is the one of these restrictions are these requirements, because quantum computing, quantum qubits are requiring these cryogenics are means very cold environmental conditions they are required for storage and working. This is the main drawback of these qubits in semiconductor industry. We require this comfortable or comfort air conditioning. Even this NASA's cold atom laboratory in precision quantum core technology was successful shipped to the International Space Station in 2019. This technology is expected to support communications, global positioning, and signal processing applications. This implementation is signaling multilateral contracts by US government agency to develop quantum atomic clock and ion trap systems. Since last 3 years they are working. This company plans to commercialize its technology in coming years, with initial goal of creating error corrected logical qubits with quantum computer. So these are some of the doubts or these general questions in the minds of general public or researchers. Some doubts are raised about that, and in this we are having some remedies or some solutions in that also. Means these are some doubts that what are application content network. These can be used to improve machine learning capabilities in financial modeling, enhance weather forecasting, and contribute to more sustainable car batteries, among other applications. Different real life examples that is in drug discovery. By making it easier to model the behavior of proteins, quantum computing is helping researchers to understand existing drugs and create new drugs to treat diseases like Alzheimer's and cancer and heart attacks. Then, what is quantum computing in AI? This quantum AI results in merging of two evolutionary domains, that is QC and AI. QC, rooted in quantum mechanics principle, claims the potential to transform computing, while AI continued its advancement in data processing. These are slight disadvantages or drawbacks are there, but this will be over advances. These computers are sensitive to noise and difficult to calibrate, because here we have to maintain that noise and soundproof and this environmental also. This complicated quantum error correction even further is quantum. Then biggest problem is with standard computers. Quantum computers are extremely susceptible to noise because we require here foolproof. This quantum state of qubits is extremely fragile, and any disturbance such as slight wave vibration or change in temperature can uncontrollably affect the computer. Because this new emerging area in semiconductor industry is the packaging of the semiconductor chips. It is one of the challenging tasks nowadays, packaging, because these are so volatile and fragile, means susceptible to noise and temperature. So these are various areas where we are using quantum computing. This is in the field of security, in finance, military affairs and intelligence, drug discovery, drug design, aerospace designing, utilities just like nuclear fusion, polymer design, machine learning, AI, big data analytics, and digital manufacturing. This some raise question: what is the future of quantum computing? Whether it will be in India successful or not? But I'm assuring you, confirming you, this will, since it is emerging area and hence it is having bright future in India. Even these technology giants, all these are working in India. They are having their offices in Hyderabad, in Delhi, Noida, Bangalore, Pune, Mumbai. So definitely they will be utilizing this and offering their services here. This will be becoming fundamental tool for scientific research. Here we have to make some key considerations and challenges for evaluating them. That is fidelity to scale. This is closely related to defining constraints, increase the number of qubits and computational speed. These individual qubits can retain their quantum state coherence for limited time to so compensate getting operations should occur fast enough to make complex computations. Multi-qubit networks will require that and control over individual qubits at scale. And cooling and environmental control. This is the main constraint here, or this main prerequisite for this. This required scale of cooling in terms of size and power is beyond the feasibility because this is required cryogenics. Here, this air conditioning engineers are required cryogenic conditions. We require that even during manufacturing. Some qubit designs use extensive production technology, while others require new technology. Hence, we will be requiring and tuning this with the latest technology. Then more qubit technology, and even this McKinsey, that is a research agency, they have find that 5 main qubit technologies will be there. These are one by one. That is photonic networks. In these networks, each qubit is encoded in a single photon. An initial cluster state is prepared and then the gate operations are executed through series of photon measurements. They have great potential for massive quantum entanglement, speed and ability to operate at room temperature. Means here this or that this can work at room temperature. Then superconducting circuits work by this encoding each qubit in energy levels of Cooper pairs on opposite side of Josephson junction. This they have worked on this. These benefits are coherence, processing speed, and ease of fabrication. Then spin qubits. These each qubit is encoded in electron spin of semiconductor quantum dots. 2 qubit gates are established between entangled electrons on silicon chip, and qubits are controlled by microwave electronics. Their small size and simplicity of fabrication is good advantage. Then neutral atoms. In this technology, a qubit is encoded in 2 hyperfine ground state levels of atom. Its advantages range from scaling to coherence and cooling. Then trapped items. Here each qubit is encoded into energy levels states. These 2 qubits exploit the coupling between the electronic and phonon between this excited electron state of ion vibrational modules of this. So here we are finding this how this is minute. Now, slight challenges of quantum computing. That is due to their fragility, qubit interconnection, decoherence, and external noise, quantum systems are prone to errors. That is the main drawback, and hence there is need to improve fault-tolerant quantum structures, qubit coherence times, and error correction methods. And this creation of quantum hardware, that is cryogenic cooling systems, control circuits, and qubit fabrication, it is also one of the challenge. Then this decoherence, and with the help of this time, this will be overcome with a proper approach to address it. The development of error correcting codes are now developed. Then scalability means mass scale. This refers to ability to increase the number of qubits to enable more complex problems to be solved. It is very complex process. Of course, one possible solution is use of error correction techniques that involve creating redundancy. Then physical implementation, different methods for building quantum computers such as superconducting circuits, trap times, and topological qubits. Then cost and accessibility, of course, cost will be more. since it is new technology, infrastructure is costly. So, but as and when this will be used on mass scale, its cost will be decreasing. Then quantum computing and AI. Here we are using this different, even this capital technology university, they have identified some of areas in which quantum computing could enhance AI in these different areas. That is parallelism and quantum acceleration. These quantum computers exploit the principle of superposition and entanglement, allowing them to perform multiple computations. This parallelism could lead to significant acceleration of AI algorithm, especially for tasks that involve processing large data sets or solving complex optimization problems. Then optimization and machine learning. In this quantum algorithm such as QAOA could be used to improve the optimization tasks in machine learning models. Then improve data processing. Here quantum computers excel at handling and processing large data. This could benefit AI applications that require extensive data processing such as PLN, image recognition and recommender systems. Then enhance encryption and security. This quantum computing is potential. This is a quantum resistant cryptographic technique to safeguard sensitive data, ensuring privacy and security of AI systems. Then exploring quantum neural networks. These offer new ways for modeling and representing complex data, which lead to more robust and expressive AI models. Then simulation of quantum systems. This capability lead to advances in understanding complex molecular interactions and design of new materials. Then energy efficiency. This lead to more energy efficient algorithms, especially for tasks that currently require extensive computational resources. Then on future of quantum computing, this and giants, technology giants, say IBM, Google, and Microsoft, they are using this and they will be becoming fundamental for scientific research. Even researchers are now making continuous efforts. Then different what industries will use quantum computing. Here this is now which Indian company is working on quantum computing. Just like here we are having HCL, Hindustan Computers Limited. This has revolutionized its strong presence in software development, in digital transformation, cloud service, is now actively engaged in quantum computing through various initiatives. Even NASA, they are also using this quantum computing in their operations. This quantum artificial intelligence laboratory of NASA, which is conducting research to determine the capabilities of quantum computers and their potential to support the agency's goal in decades to come, means new developments which are NASA is taking. It is these are real examples in which this is Janssen Pharmaceuticals. They are investigating how quantum computing can be used to make screening of potential drug candidates to be applied for molecular simulations. Then this quantum computing is how semiconductor industry is powering the future of computing. Now these qubits are fundamentally we go new. Now these are advantages of quantum computing with semiconductors. That is, quantum computers can perform certain computations much faster. Another advantage is with potential to solve the problem that are intractable or not possible through classical computers. That is, quantum computers could be used to simulate the behavior of molecules, which is used in drug discovery and material science. Because now we are having this material science or nanotechnology is used in material science, in metallurgy and other new now materials are made. And here this quantum computing is making its presence, even drug discovery. By using these quantum algorithms, quantum computers could potentially find better solutions for complex problems. With this quantum computing with semiconductor is more energy efficient, and this now investment in quantum computing. Okay, what is going on? whether since it is new technology, hence we should invest in this. It is not that. It is promising its presence, and hence every country, every developed country, they are investing huge on quantum computing. Even government of India last year they have made budget provision of 70,000 crore rupees per semiconductor industry, especially for semiconductors. Even our Honorable Prime Minister Shri Narendra Bhai Modi sir is always means encouraging the semiconductor industry progress and manufacturing and other applications in semiconductor industries. In his speech, I have listened on TV news channels. Every time he is encouraging this semiconductor new emerging industry in India. These semiconductors are also critical components for a wide range of technologies, and this investment in quantum computing is the potential part. These technology to create new industries and markets. Even governments and corporations are also investing in quantum computing semiconductor as their technological leadership. We different case studies how this is. This is the examples of companies that they are investing in quantum computing. IBM, it is leader in quantum computing for several years and is investing heavily in developing quantum computing and software. This company's quantum computing platform, IBM Quantum, is one of the most advanced in the world, and it has partnered with range of optimized organization to advance the technology. This is Google. It is a company is also having investing in quantum computing for several years and developed one of the most advanced quantum computing platforms, that is Google Quantum. This company is making significant progress in developing algorithms for a range of applications and partner with different organizations. Microsoft. This is also investing in quantum computing for last several years, and this having this platform Microsoft Quantum. This company has developed a range of quantum algorithms and partner with range of organizations to advance the technology. Then Intel, it is also one of these Intel computers we are using in our colleges, in our Intel processors are also there. This is investing in quantum computing. This company has made a range of technologies. This is used. Then Alibaba, of course, Alibaba is this leading retail house in China or e-commerce giant in China. This is also involved in this are investing in quantum computing, recognizing the potential for technology to revolutionize the range of industries. This company has developed its own computing platforms. Honeywell, it is also one of these multinational, American multinational conglomerates, heavily investing in quantum computing. And this company has also advanced computers. Then NVIDIA, its office in Pune, in Delhi. NVIDIA, it is leader in semiconductor industry. Is developing range of software and hardware solutions to support quantum computing, including its CUDA parallel computing platform and its quantum computing simulator, that is quantum development kit. This company is collaborating with range of organizations to advance the technology, and since 2019, it company is having this D-Wave Systems, that is Canadian quantum computing company, to integrate the GPU into D-Wave's quantum annealing systems. AMD, it is also one company. It is having a potential to quantum computing, and it is having its platform random instinct line of GPUs. This company is collaborating with range of organizations, and since 2020, this company has partnership with Cambridge Quantum Computing, that is UK-based quantum computing software company, to develop quantum computing algorithms and software. So here, these are the future of semiconductors and advancements and innovation to watch what is going on in future in there. The semiconductor industry is at the forefront of technology innovations for decades, now driving progress in computing, communication, and consumer electronics. This industry is seeing significant advancements in material science with development of new materials and process that enable the creation of smaller, faster, and more energy efficient chips. This is the new creation or new innovations, because these chips now we are seeing that, take example of simplest example you and me are using, even general any person who is using computer, laptop or computer, we are using these pen drives. And imaging this pen drive, its weight is hardly 5 to 6 gram and its size is hardly 2 inch. And imagine the how much capacity of data storage in this small compact electronic material or product. This is becoming so narrow, so nano size, so compact size, and in size it is beyond control. Even we can means store the data in PDF form nearly 2 to 3 rooms of our college or our laboratories or in our residence rooms. Suppose we store that books or journals in that our rooms, and all this data is in PDF form in this 2 inches long pen drive and hardly 5 to 6 gram weight. It's very compact size. Means this is this nano now materials are now made. Nanotechnology is taking its shape. Here the semiconductor is taking its presence. Means smaller, faster, and more energy efficient chips. By using these high K dielectrics and metal gates allowed for creation of transistors with better performance and lower power consumption. Even some new exciting innovations and trends to watch for semiconductor industry. Here this quantum computing is emerging as new technology. Then neuromorphic computing. This involves the development of computer chips that mimic the structure and function of human brain. It has potential to revolutionize the computing industry and lead to development of more efficient and intelligent machines. This silicon photonics. This is technology that uses light to transfer data between computer chips. It has potential to revolutionize the data centers with more faster data, faster and less power consumption. Then advanced packaging. This is I'm telling you. This is the new means emerging area or this main where these semiconductors are required. Advanced packaging because semiconductor chips are so volatile and fragile. Here, these advanced semiconductor packaging technologies are playing a critical role in enabling development of high performance and power efficient electronic devices. These offer range of benefits including improved thermal management, higher bandwidth, smaller form factors, and greater integration density. Then memory solutions. With the rise of this big data, artificial intelligence, and machine learning, there is big demand for advanced memory solutions such as high bandwidth memory (HBM) and 3D NAND flash and other emerging memory technologies. Then next gen process technologies. New technologies such as extreme ultraviolet UV lithography and FinFETs and transistors will enable the manufacturing of small and more powerful semiconductors. These advancements are this will enable better utilization of computing resources, and here we are finding how this quantum computing is used here. This is virtual cycle AI and quantum computing. This quantumation emphasizes the mutually beneficial relation between AI and computing technology, quantum technologies. Different this quantum for AI, that is faster training and interference. Quantum machine learning is active research area. Then quantum inspired classical algorithms in which these tensor networks developed for quantum physics are developed for linear algebraic problems on classical computers. Then better training data, enhanced privacy and security. Then AI for quantum means both are working for each other. Quantum for AI and AI for quantum. This AI for artificial intelligence for quantum, that is quantum processor design optimization. Here machine learning assists in design and simulation of quantum processors. Improved calibration and control. Better machine algorithms can enhance the calibration and programming of quantum systems, reducing errors. Then optimization in variational quantum algorithms. Hybrid algorithms which combine classical and quantum computing can benefit from improved machine algorithm techniques. Then automated translation of classical code to quantum algorithms. The different practical examples are there where researchers and entrepreneurs are exploring paths to quantum. Here we are finding these practical examination examples where how this is used, quantum computing and AI are used. That's it, qubit pharmaceuticals. These quantum accelerated simulators help train better machine learning models for drug discovery, creating virtual cycle of improved data and models. Then multiverse computing. This developed compact AI, that is quantum inspired approach that significantly accelerated training of large language models LLMs. Then Pascal, leveraging analog computing programming with neural atom computers to implement graph neural networks. These problems in logistics, social networks, and biological processes. So here, what is this future of semiconductors, advancements, and innovations to watch for? Here, these innovations, these several innovative solutions like quantum computing, silicon photonics, and next-gen process technologies tapping this new shape. Then applications, several new consumer and enterprise applications will get created on top of the neck, which we have never seen in this. Then both technical and business progress will occur and forefront that semiconductor technology is at the forefront of this. Now, these are some of these top and growing applications where advanced computing semiconductor solutions are playing their role, that is in AI. This AI is becoming increasingly important in different industries, and semiconductor helps to improve that complex calculations and tasks quickly and efficiently. Autonomous vehicles, just like we are having this autonomous and drones, even driverless cars, driverless vehicles, the semiconductors are used in large amount of data. Then pneumomorphic vision sensor. These sensors develop to mimic the human eye and brain to lead to development of more efficient intelligent image processing systems. Then wide band gap semiconductors. These such as silicon carbide and gallium nitride. These enable more efficient power conversion and management in different applications such as in electrical vehicles and renewable energy systems. This is positive impact of quantum computing on AI. That is, data can be processed faster by quantum computers. Quantum computers can handle complex problems. Many applications such as planning and scheduling is benefited with the help of quantum computing. Even these Shor's algorithms can be used to factor large numbers and quantum computers can simulate quantum systems more efficiently. By using quantum annealing, problems that cannot be solved by conventional, this can be used here. These quantum computers are These AI systems can use quantum computers to protect sensitive data. So these are these different applications areas of quantum computing and AI both. Resolve complex problem in short period. These data sets are becoming increasingly complex and larger. And today's computers are with quantum supremacy, that is ability to this. Google claim to have achieved uh, the computations that typically take thousands of years now can be just in 200 seconds. Imagine the speed of this computing, quantum computing. The means last 5 years back, this processing which was taking number of thousands of years, and now this is just completed within 200 seconds. Mean, imagine the supremacy of quantum supremacy or importance of quantum computing. Then managing large data sets. Then detecting and combating the frauds. This quantum computing and AI are used in banking and financial industries. Fraud detection will be improved and enhanced. Nowadays, we are finding majority of the fraud or these cyber attacks are on these financial institutions or banks. Even when we are dialing our mobile from our mobile to any our friend or any colleague, nowadays since last 15 days I am listening this on our mobile phone. As and when we are dialing any number, this 10 to 12 seconds message is coming. Ki do not become the victim of these cyber criminals or cyber attacks. Means even government of India is also encouraging or awareing this common citizenship, general citizens. Ki do not become prey to these cyber attacks. Means take precautions in that. So here this quantum computing and AI, they are means helping to detect and avoid these fraud detection and even in this online transactions, misuse of these online transactions. Then developing better models. Then it is estimated that by this end of this year, healthcare industry's data generation will grow at compound annual growth of 36%, which is 6 times faster than manufacturing, financial, and services. Means 36% this data will be increase in healthcare industry. By using this quantum technology to develop better models, we will be able to treat illness more effectively, reduce the risk of financial collapse, and improve the coordination. Even medical field and accuracy predicting traffic volumes in transportation. Here we are finding that in traffic jams or in this logistics, this will be predicting the accurate traffic solutions. Even quantum computing is expected to play a crucial role in advancing our biology and evolution, just like we have seen that in molecular science, enabling more effective treatments for disease such as cancer and in mitigating the effects of climate change also. So these breakthrough redefining industries. Some quantum machine learning. This is beyond theoretical bounds. Even this Hydro-Hasidium Lloyd algorithm has shattered previous limitations and offering unprecedented computational speeds. This acceleration of data processing is enabling real-time analytics and decision making, even quantum annealing, addressing today's challenges. This, particularly through D-Wave's advancements, has evolved beyond experimental stage, now delivering practical solutions for optimization from even from enhancing traffic management system to financial portfolio management. Quantum annealing is providing indispensable for industries. Even error correction. Enhanced error correction methods have made quantum systems more stable and reliable, encouraging their adoption in sectors where precision and reliability are paramount, such as finance and healthcare. Because finance, even you see, majority of even you might have read or listen in TV news channels and on these social media platforms and other news reports. Those computer experts, those who are having mastery in computer science, computer field, they are also becoming the victims of the cyber criminals in financial transactions. Means these finance are these banks or these financial transaction are these applications of this technology, which is just one button click. If you click OK button and all transactions are transacted at the click of one button, and whole bank account is means our bank balance is becoming just like nil at the minimum level. Means lakhs and crores of rupees are transacted just at the click of one button. And this now cyber criminals are so becoming smart, even they are bypassing these our mobile SMS alerts. But here quantum computing is providing this help here, and it is protecting the customers and consumers. Then transformative impacts across industries, that is in drug discovery and material science. This financial industry is also having in this. And this quantum key distribution, it has emerged from these theoretical models. And this is heralding new era for security based on principles of quantum mechanics. Yes, here we are finding. Now, this industry is currently exploring or utilizing quantum technology, and semiconductor technology includes healthcare, finance, material science, energy, aerospace, cybersecurity, pharmaceutical, logistics, and government research. With companies like IBM, Google, Quantum, AI, Microsoft, and Intel, they are these market leaders in these four companies, and all these are working in India. Even majority of the its products we are using day to day life. So they are using in this. These are key points about this intersection, that is semiconductor as building blocks. These quantum computers rely heavily on advanced computer technologies, semiconductor techno, to create necessary quantum bits or qubits. This simulation potential, quantum computing excels at simulating complex systems, making it valuable for designing new materials, optimizing chemical reactions, and modern molecular interactions in pharmaceutical and healthcare. Then cryptography challenges. Even quantum computing could potentially break current cryptography methods, driving the need for new quantum resistance cryptography solutions in cybersecurity. These different examples are in healthcare. Now, in healthcare, developing new drugs by simulating molecular interactions, analyzing large genetic data sets, and improving this medical imaging. Then finance, optimizing investment portfolios, managing risk, and developing advanced financial modeling techniques. Then material science, designing new materials with superior properties like high performance batteries or lightweight composites. Because new developments are going in electric vehicle batteries. Its weight is nanotechnology is used, in which in its weight is reduced, and moreover the main drawback of this electrical vehicle, which is finding we are finding, it is overcharging and overheating. And new materials are developed with the help of this quantum computing, in which now this means life of the battery will be improved with the help of this. Then energy, developing new energy sources, improving energy grid efficiency, simulating complex quantum phenomena in nuclear fusion research. Aerospace, optimizing aircraft design, improving fuel efficiency, and simulating complex aerodynamic conditions. This quantum computing is used. Now, in June 2023, last year, IBM unveiled the significant milestone featuring the scientific journal Nature, establishing for the initial time that quantum computers can generate precise outcomes at magnitude of 100 plus qubits, surpassing the classical methods. Even in December last 2023, IBM unveiled the IBM Condor, a groundbreaking quantum processor with 1121 superconducting qubits at IBM Quantum Summit. These are the results as they have declared on their website. All these companies have achievements. So, so these companies, they are on their website, they are declaring this is the latest data which is available on this company's website. I have taken this data last week. Alongside this, it introduced the quantum Heron processor, which is featuring 133 fixed frequency qubits and tunable couplers, boasting 3 to 5 times performance enhancement over previous models. This Google Quantum AI. These Google Quantum researchers achieved a notable milestone by reducing quantum computing errors through increase of qubits, shifting to treating multiple physical qubits as one logical qubit and enhancing performance, as is highlighted in company's blog post authored by company CEO in February last year. This Microsoft. The company announced several updates, including Azure Quantum Elements, new system that seeks to expedite the advancements in chemical and material science by leveraging the scale of Azure high performance computing and the swiftness of AI. Along with this, there are launch of Copilot in Azure Quantum to assist scientists in utilizing natural languages to navigate through complex problems in chemistry and material science. This company, Microsoft, announced the roadmap of Microsoft's quantum supercomputing, making its first milestone making public with corresponding peer-reviewed research as strategic acquisition into photonic incorporation. Because these data are they are declaring officially, they are declaring on their website, or some where this exchange of or some meetings or conferences or companies meetings are there, and on that this platform they are sharing their data, what is the latest in their companies in particular area in quantum computing. Then Amazon brackets in November 2023, This AWS announced the launch of an innovative quantum computer chip designed in-house that significantly advances error correction capabilities. This new chip is capable of reducing this bit chip errors by a factor of 100 to a passive error correction. Means they have reduced these errors. This, when combining passive with active error correction techniques, this chip has potential to perform quantum error correction 6 times more effectively as compared to previous. Means they have increased its speed and perform this 6 times more effectively than Alibaba Group. In June 2024, this company's blog Alibaba Cloud Technology published a post on developments in Alibaba's cloud computing infrastructure. This company notes a sustained emphasis on research and development. It's a strategy for continuous growth and transformation. This Alibaba's quantum laboratory is leading to the dismissal of over 2,000 employees. This development has sparked widespread speculation among experts, with some whether this closure reflects Alibaba's financial challenge to integrate broader issues with quantum industry. Then Baidu, which is from China, during its annual flagship developer conference, Baidu in 2022 announced and unveiled its quantum computing strategy (QN), aiming to bridge the gap between quantum hardware and practical applications. This QN stands for Quantum Basic Research Infrastructure Construction, application of quantum technology and network ecosystem. Through this strategy, Baidu aims to incorporate quantum computing across various industries, working towards scenario where quantum computing is more accessible than Intel. In June 2024, this company unveiled its latest quantum research chip, Tunnel Falls, a 12-qubit silicon chip, extending its availability to the quantum research community. This Intel is partnering with Laboratory for Physical Sciences at University of Maryland, Park's collaborative, that is Distinguished National Quantum Information Science Research Center, to propel the advancement of computing research center. Means they are working on this and they are having MOU with here University of Maryland College, uh, Park's Qubit Laboratory, and Intel. Then NVIDIA. In March 2023, last year, NVIDIA launched this DGX Quantum, the first ever GPU accelerated quantum computing system, integrating this NVIDIA Grace Hopper superchip with Quantum Machines OPX quantum control platform. This system synchronizes advanced classical and quantum computing, supporting functions like calibration, control, and quantum error correction. With this NVIDIA Grace Hopper GPU connected to quantum machines, OPX Plus via PCIe offers markedly low latency and powers large-scale AI and HPC high-performance computing workloads efficiently, promising up to 10-fold performance. Means they have achieved this 10 times increase in performance improvement for quantum classical research applications. Then Atlantic Computer Quantum. This founded in this 2022, Atlantic Quantum is the result of this consortium of scientists and researchers hailing from STEM Engineering Quantum Systems group at MIT under the leadership of Professor William D. Oliver and Principal Research Scientist Simon Gustafsson. That this atom computing and US Department of Energy National Renewable Energy Laboratory (NREL) they revealed a partnership in July last year to investigate the potential of quantum computing in enhancing electric grid operations. And even in October 2024, this atom computing announced its pioneering next generation quantum computing platform boasting 1, 2 to 5 site atomic spray populated with 1180 qubits, marking the first instance a company has surpassed 1000 qubit milestone for universal gate based system. Then Qubit Pharmaceuticals. This Qubit Pharmaceutical is a bridge or collaboration between world of mathematicians and physicists physicians, physics professionals who are developing high-speed computational tools based on quantum research, and pharmaceutical and biotech industry in the search of new drugs. By creating these digital twins of molecules and simulating their behavior, the company is confident of to become a globally recognized player in development of new drugs in areas where unmet human needs remain insignificant, because they are working in this molecular biology and also in pharmaceutical and biotech industries. Pharmaceutical and biotech industries. Then emergence of quantum computing as a source QCAS is gaining significant increasing interaction. With this proliferation of quantum computing and accessible platforms, IBM, Microsoft Azure, Google Cloud, and AWS bracket computing, quantum computing companies and other entities are now actively participating in quantum revolution, offering quantum computation power to broader audience. These companies are now exploring how to provide private cloud and hosted services to deal with strict data privacy and requirements for end customers. Then recent developments in quantum computing for semiconductor design. This recent development have made it possible to integrate this technology into semiconductor industry. One is a improved grid stability, which is critical for reliability of quantum systems. Quantum systems can now handle more complex computations and error correction techniques, and making quantum computing more efficient and reliable in practical applications for semiconductor design. At the same time, this semiconductor industry is moving towards a smaller nanometer fabrication process with chips as tiny as 5 nanometer and 3 nanometer. Means imagine what is the size in nanotechnology. Now these developments are happening in this. This trend enables more transistors to be integrated into a single chip, thereby increasing performance and energy efficiency. This, moreover, research is also going in alternative materials such as graphene and silicon carbide. New of these materials are likely to be replaced or made in as a graphene and silicon carbide to enhance the semiconductor capabilities. Even this innovations in chip architecture such as 3D stacking are also going on to overcome the limitations of traditional planar design, ensuring continued progress and innovation in semiconductor technology. Now, engineers are exploring the potential of quantum computing to drive these technological advancements. Now, using this technology to optimize transistor layouts in semiconductor design, they can now achieve more precise simulations that minimize leakage currents, improve switching speeds, and enhance the overall performance at the time of maintaining energy efficiency. Additionally, quantum error correction techniques are ensuring robustness in real-world applications. Here we are finding this. I will tell you different this new innovations which are and trends which are happening or undergoing in semiconductor industry. That is neuromorphic computing, in which this is computing neuromorphic is involving the development of computer chips that mimic the structure and function of the human brain. Imagine how this development is going on. It has the potential to revolutionize the computer industry and lead to development of more efficient and intelligent machines. Then silicon photonics. This is the technology that uses light to transfer data between computer chips. It has the potential to revolutionize data centers as it can move data faster with less power and traditional copper wires. Then advanced packaging. This is also one of these challenge, because these silicon semiconductor chips, these are so fragile, so means sound means prone to sound and temperature, and hence these packaging advanced packaging, advanced packaging technologies are going on. Developments in this are critical means to protect its performance, and so that minimum errors are there, or error-free performance is there for the development of these high performance and power efficient electronic devices. This packaging offers a range of benefits including improved thermal management, because this requires these cryogenic conditions, and hence we have to maintain that comfort, air conditioning, higher bandwidth, small form factor, and greater integration density. This is all these are maintained with the help of this advanced packaging. Then memory solutions are also happening. New developments are going on in which, with the rise of this big data analytics, AI, and machine learning, there is growing need for advanced memory solutions such as high bandwidth memory and 3D NAND flash. And of course, this is a total of this is electronic items. Electronic engineers, they do better know how these are made. And emerging memory technologies. Then new process technologies such as extreme ultraviolet lithography and FinFET transistors, these enable the manufacturing of smaller and more powerful semiconductors. These are the specific sets of applications that will be the game changers. This will be making any industry in the market innovative applications, and these developments, these enable better use of computing resources, thus bringing more attention to semiconductor solutions and critical future requirements. These developments are going on in semiconductor industry. Even government of India is encouraging this industry. Special budget provision have been made. Nearly 70,000 crores of rupees is specially booked or reserved for the semiconductor industry. Even our honorable Prime Minister is also always advocating for the semiconductor industry to popularize this, to make research in this. And these 4 to 5 players, those who are in India, they are working on this, and they are investing heavily in quantum computing. And they are market leader: IBM, Google, Microsoft, Intel. Now, Alibaba, of course, this is Chinese company. Its presence is not in India, but this company is having its presence leading leading leader in China, Alibaba. Even the owner of Alibaba Group in last year, he was means not traceable for 1 month, and the rumors were what is the future or what is the life of that Alibaba Group. Later, he was coming in actual, but 1 month he was in absence. The rumors were some news channels, some rumors were there about the owner of this Alibaba. Means imagine if any owner of any group is missing, his presence is not seen, then how it makes news reports are this breaking news. And Alibaba is more popular in China. Of course, this company is in a retail showroom, just like we are having here Super Bazaar, D-Mart, and Best Price. Alibaba is same in China. But this is also in working in semiconductor industry also, in quantum computing. And this Honeywell, this is also American company. So here we have seen that majority of these multinational companies, almost more than 80% of the companies, these are of US base, and developments are going in that. And NVIDIA, it is having its presence in India. This company is working in India. In Pune, this company is having its office. In Delhi, Noida also. In Bangalore also it is having. But Pune, I have no confirm. I have seen that office in Pune also, in NVIDIA. This is offering this range of software and hardware solutions. And AMD is also one of this. So they are making this, offering their latest products, and with means if you see here, hardly 8 to 10 companies are leading companies at world level. Of course, this is the totally nascent technology. New developments are going, but in India also we are utilizing this. Even NASA is also utilizing this. In one of the slides, we have seen that how NASA is using for its space applications, quantum computing. Of course, this NASA and ISRO, they are not declaring, because these are this monopoly are these more sensitive areas, hence they are not declaring their innovations in public platform. But research is going on. Whereas these commercial companies, they are publishing, and officially they are publishing on their websites, on their platforms. Okay, what is going and what was the latest, whichever is latest I have taken from this company's websites and included in these slides. And this is the which I have taken this data last week. Okay, this is the of these companies' data. It is the which is officially available on their websites. I have taken this data from their official websites, whichever they have declared on their websites. So means we should assume that this is the latest data in this quantum computing in semiconductor industry. Now from my side, it is okay. From now participant side, if any questions or suggestions, welcome. Or anybody wants to elaborate more or share, if they are having any additional knowledge, welcome.
Participants, if you have any question, can ask them.
Yes, any questions or any suggestions, or if you want to enhance further, if you are knowing better than this, welcome, so that all your colleagues will be benefited.
So no questions from
And I am
participant side.
okay.
Thank you, Dr. Ashok G. Matani, sir, for an enlightening and engaging session. Your insights into the transformative potential of quantum computing in semiconductor industries have truly inspired us all. I would like also to extend my heartfelt gratitude to everyone in the audience for your active participation and enthusiasm. Let us continue exploring and innovating in the exciting field together. Thank you once again and have a great day ahead. Thank you so much, sir. Participants, please turn on their cameras for a moment, as we need to take screenshots for documentation purpose. These screenshots are required to fulfill the guidelines for this FDP and to ensure proper record keeping. Once the screenshots are taken, you may turn off your cameras if you wish. Please turn on their cameras. Participants, technical team, please take the screenshot. There will be an important announcement for participants. Please note that session 11 will begin at 2 p.m. tomorrow. So all the participants can join the session at sharp 2 p.m. After the final session, there will be an assessment test. The timings is 6:30 p.m. to 7:30 p.m., which will consist of 30 MCQ type questions. The assessment exam and final feedback will be accessible through the ATAL portal login. You also know that attendance required for certificate is 80% or more, and test score, assessment score is more than 70% in the test conducting on the last day. So I have shared the feedback link. Please check the chat box.
Sir, feedback link is not available. Please provide it.
Okay. Please fill the feedback form.